Welcome. Tonight, we dive into a world that feels almost unreal, a world where the rules of nature seem slightly broken, where creatures drift like living enigmas, and the boundary between the familiar and the impossible begins to blur. Beneath the vast, shifting surface of the ocean, there exists a being so strange, so unexpected, that even seasoned scientists struggle to fully understand it. It is enormous, yet delicate, ancient, yet oddly vulnerable. And at first glance, it doesn't even look like a fish at all. This is the story of the ocean sunfish. The ocean covers more than 70% of our planet. It is a place of extremes, of crushing pressure, freezing darkness, and endless silent movement. Yet even here, among countless species shaped by millions of years of evolution, one creature stands apart. Imagine, for a moment, a fish. You might picture something sleek, streamlined, built for speed, a creature perfectly adapted to cut through water with precision and grace. Now, forget all of that, because the ocean sunfish defies every expectation. At full size, it can weigh over 1,000 kilograms. That's heavier than a small car. Its body is tall, flattened, and strangely truncated, as if nature began designing a normal fish and then simply stopped halfway through. There is no traditional tail. Instead, what should be a powerful, sweeping fin is replaced by a stubby, almost unfinished structure known as a clavus. It doesn't propel the fish forward in the way we would expect. Instead, the sunfish moves in a way that seems almost awkward. Using its dorsal and anal fins, it flaps through the water in a slow, rhythmic motion, not side to side like most fish, but up and down, like a bird attempting to fly through liquid. And yet, despite its unusual design, it survives. But survival in the ocean is never simple. The deeper you go, the more unforgiving the environment becomes. Light fades, temperatures drop, pressure builds to levels that would crush most living things in an instant, and the sunfish travels through all of it. During the day, it often dives into the colder, darker depths in search of food. Jellyfish, soft-bodied organisms, drifting prey, these are its primary targets, creatures that many other predators ignore. But hunting in the deep comes with a cost, because when the sunfish returns to the surface, something extraordinary happens. It stops. It drifts. And then, in one of the most unusual behaviors in the animal kingdom, it turns on its side. Floating there, almost motionless, it appears as though it has given up, as though it is no longer alive. For years, sailors who encountered this strange sight believed they were witnessing a dying creature, a fish at the end of its life, surrendered to the waves. But the truth is far more fascinating. The sunfish is not dying, it is sunbathing. After spending time in the cold depths, its body temperature drops, muscles slow, energy fades, and so it rises to the surface, where the warmth of the sun helps it recover. But that's not the only reason. Floating at the surface also attracts visitors, small fish, birds, even parasites. The sunfish's massive body often becomes home to countless tiny organisms. Parasites cling to its skin, feeding and multiplying. And the sunfish allows it, because when it lies still at the surface, cleaner fish and seabirds take notice. They approach cautiously, then begin to feed, picking parasites from its body in a delicate, mutually beneficial exchange. A giant becoming a floating cleaning station.
But this strange behavior raises a deeper question. How did a creature like this evolve? In a world where speed often means survival, where agility and efficiency dominate the food chain, how does something so slow, so exposed, continue to exist? The answer lies in a different kind of strategy. Not speed, but scale. The ocean sunfish produces more eggs than almost any other vertebrate on Earth. A single female can release hundreds of millions of eggs at once, tiny, nearly invisible spheres drifting into the vast ocean. Most will never survive. They will be eaten, lost, destroyed by currents or predators. But a few will endure. And those few will grow into something extraordinary. The early life of a sunfish is almost unrecognizable. As larvae, they are small, spiny, and bear little resemblance to the massive, smooth-bodied giants they will become. They drift with the currents, vulnerable to everything around them. Every shadow is a threat. Every movement could mean danger. But as they grow, something remarkable happens. They begin to transform. Their spines shrink, their bodies expand, their strange flattened shape emerges. And with each passing stage, they become harder to prey upon, until eventually they reach a size where very few creatures dare to attack them. Yet even giants have enemies: large sharks, orcas, and perhaps most dangerous of all, humans. Fishing nets, plastic pollution, and changing ocean conditions have all begun to affect sunfish populations. Though they may seem abundant in some regions, their future is far from certain. Because survival in the ocean is no longer just about evolution. It's about adaptation in a rapidly changing world. And still, the sunfish drifts on. Across vast distances, carried by currents, guided by instincts we are only beginning to understand. Some have been tracked traveling thousands of kilometers, crossing entire ocean basins in silent, solitary journeys. Where are they going? What are they following? The answers remain elusive. There is something almost hypnotic about the ocean sunfish. Perhaps it is the way it moves, slow, deliberate, as though time itself has little meaning. Or perhaps it is the mystery that surrounds it. A creature so large, yet so gentle, so visible, yet so misunderstood. It challenges our assumptions. It reminds us that nature does not always follow the patterns we expect, and that sometimes the most unusual designs are the ones that endure.
But the deeper we look, the more questions emerge. What secrets lie beneath its seemingly simple behavior? How does it navigate the endless ocean? And what unseen forces shape its journey through the depths? Because this is only the beginning. The ocean sunfish is not just a curiosity. It is a gateway into a hidden world. A world where survival takes unexpected forms, and where every movement tells a story waiting to be uncovered. In the next chapter, we will dive deeper, beyond the surface, beyond the sunlight, into the darker, colder layers of the ocean, where the sunfish faces challenges few creatures can endure, and where its true nature begins to reveal itself. Stay with us. The surface of the ocean is an illusion. From above, it appears calm, almost peaceful. Sunlight dances across gentle waves, and for a moment it feels like a world we understand. But just beneath that thin, shimmering boundary, everything changes. Light fades rapidly, colors vanish, temperature drops, and with every meter deeper, the ocean becomes less like home and more like an alien realm. It is here, between light and darkness, that the ocean sunfish begins one of its most mysterious journeys. At first glance, the sunfish seems like a creature of the surface. Its habit of drifting under the sun, its slow, almost lazy movements, it gives the impression of an animal that belongs to warm, shallow waters. But this perception is misleading, because the sunfish is a traveler between worlds. As day begins, many sunfish descend. Not slowly, not reluctantly, but with purpose. Tracking devices have revealed something astonishing. These massive creatures regularly dive hundreds of meters below the surface. Some even reach depths of over 600 meters, where sunlight can barely penetrate. Down here, the ocean is cold, sometimes just a few degrees above freezing. For most fish, such a drastic temperature shift would be dangerous. Muscles would stiffen, metabolism would slow, reaction time would suffer. But the sunfish continues. Flapping its fins steady and unhurried, it moves through layers of water that would challenge even the most adapted marine predators. Why? The answer
lies in what waits below. In the dim, drifting darkness, an entire ecosystem exists, fragile, gelatinous, and often invisible to the human eye. Jellyfish. They pulse softly through the water, their translucent bodies glowing faintly in the fading light. To many predators, they are not worth the effort. Low in calories, difficult to grasp, sometimes even dangerous. But to the sunfish, they are essential. The sunfish's diet is surprisingly specialized. Despite its enormous size, it feeds primarily on soft-bodied organisms, jellyfish, salps, and other gelatinous creatures, food that provides relatively little energy compared to the effort required to find it. Which raises an obvious question. How does something so large survive on something so insubstantial? To answer that, we must look closer. The sunfish is not built for speed, but it is built for endurance. It doesn't chase its prey in bursts of energy. It doesn't rely on sudden attacks or high-speed pursuits. Instead, it drifts, patiently, persistently, through areas where jellyfish are abundant. Its mouth, small compared to its body, is uniquely adapted. The teeth are fused into a beak-like structure, allowing it to grasp slippery prey that would otherwise escape. And once captured, the jellyfish have little chance. But feeding in the deep is only part of the story, because every descent comes with a cost. As the sunfish moves into colder waters, its body temperature drops, energy consumption increases, and over time, its ability to function becomes compromised, which is why it must return, back to the surface, back to the warmth. This daily migration, from warm to cold, from light to darkness, is a delicate balancing act. Too much time in the depths, and the cold becomes dangerous. Too little, and it cannot find enough food to survive. Somehow, the sunfish manages to maintain this balance. Not perfectly, not predictably, but consistently enough to endure. Yet the deeper scientists look, the more complex this behavior appears. Because these dives are not random. They follow patterns. Patterns influenced by temperature gradients, by ocean currents, and perhaps even by something we do not yet fully understand. Navigation.
How does a creature like the sunfish find its way? There are no obvious landmarks in the open ocean, no mountains, no trees, no visible paths, just endless water. And yet, tagged sunfish have been observed traveling across vast distances with surprising consistency. They don't simply drift aimlessly. They choose directions. They follow routes. They return to regions they have visited before. One theory suggests that sunfish use temperature differences to guide them, moving between layers of water that feel familiar. Another possibility is that they sense Earth's magnetic field, much like sea turtles and migratory birds. Or perhaps there is something else, something subtle, something we have not yet learned how to measure. Because the ocean is full of signals, invisible currents, chemical traces, vibrations that travel through water in ways we barely comprehend. And the sunfish may be tuned in to all of it. But even with this remarkable ability, survival is never guaranteed, because the deeper regions of the ocean are not empty, they are watched. In the shadows, predators move. Large sharks patrol the depths, their senses finely tuned to detect even the faintest sign of movement. Orcas, intelligent and coordinated, are known to target sunfish with surprising efficiency. Unlike other prey, the sunfish cannot escape with speed. It cannot outmaneuver its attackers. So how does it survive? Part of the answer lies in its size. A fully grown sunfish is not an easy target. Its thick skin, which can be several centimeters deep, offers a degree of protection. Its sheer mass makes it difficult to subdue. But size alone is not enough, because predators are patient, and the ocean rewards patience. There have been observations, rare, fleeting moments, where orcas have been seen attacking sunfish in a coordinated effort, flipping them, disorienting them, turning their unusual shape into a disadvantage. In these moments, the sunfish's strange body, so effective in its own way, becomes a vulnerability. And yet, these encounters are not the norm, because the sunfish, despite its apparent clumsiness, has one unexpected advantage: unpredictability.
It doesn't move like other fish. It doesn't follow the same patterns. Its slow, drifting motion can make it difficult to track, difficult to anticipate, and sometimes, in the wild, being different is enough. Still, not all threats come from natural predators. In fact, the greatest danger to the sunfish may not lurk in the depths at all. It may come from above. Human activity has reached even the most remote parts of the ocean. Fishing operations designed to capture entirely different species often unintentionally trap sunfish in their nets. Unable to free themselves, these massive creatures can become entangled, helpless against materials they do not understand. Plastic pollution presents another silent threat. Floating debris, mistaken for jellyfish, can be consumed with devastating consequences. A plastic bag drifting in the water looks eerily similar to the sunfish's favorite prey, and in the vast ocean, a single mistake can be fatal. Then there is the changing climate. As ocean temperatures shift, so too do the movements of jellyfish populations. Entire ecosystems are beginning to reorganize, forcing creatures like the sunfish to adapt.
Every giant begins as something small. So small, in fact, that it is almost impossible to imagine what it will become. Drifting somewhere in the vast openness of the ocean, invisible to the naked eye, the life of the ocean sunfish begins not as a giant, but as a fragile spark of possibility, a single egg. In the world beneath the waves, survival is often a game of numbers, and the sunfish plays this game on a scale that is almost beyond comprehension. A single female ocean sunfish can release hundreds of millions of eggs at once, more than almost any other vertebrate on Earth. It is an overwhelming number, a silent explosion of life scattered into the currents. But within this abundance lies a harsh truth. Almost none of them will survive. The ocean is unforgiving to the young. From the very first moment, danger is everywhere. Tiny predators, drifting plankton feeders, even the currents themselves, all pose a threat to these microscopic beginnings. There is no protection, no parental care, no safe haven, only chance. And yet, life persists. From this vast cloud of eggs, a small fraction begins to develop. They hatch into larvae so strange, so unlike the adult sunfish, that for a long time, scientists struggled to connect the two stages of life. Covered in tiny spines, with a more recognizable fish-like shape, the larval sunfish looks almost like a completely different species. It is armored, defensive, and alert, a sharp contrast to the smooth, drifting giant it will one day become. At this stage, every movement matters. The larva must feed, must grow, must avoid being eaten. Its world is filled with threats, but also with opportunity. Microscopic food particles drift through the water, plankton, organic matter, fragments of life carried by the currents. If it can consume enough, it grows. And growth changes everything, because the ocean sunfish is one of the fastest growing vertebrates on the planet. From a creature smaller than a grain of sand, it begins a transformation that is nothing short of extraordinary. Within months, it expands, its body reshapes, its defenses shift, the spines that once protected it begin to disappear, the familiar, strange outline of the adult sunfish slowly emerges. But growth does not guarantee survival, because as the sunfish grows, so do the dangers. At intermediate sizes, it becomes a target, too large to remain unnoticed, yet too small to defend itself effectively. Predators are everywhere: larger fish, marine mammals, opportunistic hunters that patrol the open ocean in search of easy prey. At this stage, speed can mean survival, but the sunfish is not built for speed. Instead, it relies on something else, a combination of rapid growth and constant movement. It does not stay in one place for long. Carried by currents, guided by instinct, it moves through different regions, never lingering long enough to become predictable. In a world where being predictable can mean death, this unpredictability becomes a form of protection. And then, something remarkable happens.
But this strange behavior raises a deeper question. How did a creature like this evolve? In a world where speed often means survival, where agility and efficiency dominate the food chain, how does something so slow, so exposed, continue to exist? The answer lies in a different kind of strategy. Not speed, but scale. The ocean sunfish produces more eggs than almost any other vertebrate on Earth. A single female can release hundreds of millions of eggs at once, tiny, nearly invisible spheres drifting into the vast ocean. Most will never survive. They will be eaten, lost, destroyed by currents or predators. But a few will endure. And those few will grow into something extraordinary. The early life of a sunfish is almost unrecognizable. As larvae, they are small, spiny, and bear little resemblance to the massive, smooth-bodied giants they will become. They drift with the currents, vulnerable to everything around them. Every shadow is a threat. Every movement could mean danger. But as they grow, something remarkable happens. They begin to transform. Their spines shrink, their bodies expand, their strange flattened shape emerges. And with each passing stage, they become harder to prey upon, until eventually they reach a size where very few creatures dare to attack them. Yet even giants have enemies: large sharks, orcas, and perhaps most dangerous of all, humans. Fishing nets, plastic pollution, and changing ocean conditions have all begun to affect sunfish populations. Though they may seem abundant in some regions, their future is far from certain, because survival in the ocean is no longer just about evolution.
And somewhere, in the endless blue, a young sunfish continues its journey. No longer a larva, not yet a giant, but something in between. A living reminder that even the strangest forms of life have a beginning. In the next chapter, we will explore the hidden relationships that shape the life of the ocean sunfish. The creatures that depend on it, the organisms that live on it, and the delicate balance between cooperation and survival. Because in the ocean, even a giant is never truly alone. Stay with us.
The ocean sunfish, for all its size and strangeness, does not exist in isolation. The ocean is a living web, and even a creature as immense as the sunfish becomes a hub, a platform, a host for countless smaller lives. As it drifts through the currents, something remarkable occurs. Tiny organisms approach, almost instinctively, sensing opportunity in the presence of this unusual giant. Parasites. They cling to its skin, small and persistent. These hitchhikers feed on the sunfish's flesh, multiplying with near invincible patience. Left unchecked, they could weaken it, slow it down, or even harm it. Yet the sunfish seems almost indifferent. Instead, it relies on allies. Cleaner fish are the sunfish's most frequent companions. These small, nimble species approach with caution, inspecting every fold, every wrinkle, every shadow of its massive body. They dart in and out, plucking parasites and dead tissue with precision. A delicate partnership, a give and take. The sunfish offers shelter, and in return, it gains relief from its tiny tormentors. Even seabirds join the cleaning effort when the sunfish surfaces. They hover, alight on its back, picking at parasites with the same efficiency. It is as though the sunfish's massive presence becomes a floating island, a mobile ecosystem in an otherwise vast, empty sea. This strange symbiosis raises questions about the complexity of life beneath the waves. Why do these relationships exist? How has evolution crafted such interdependence? The ocean is often seen as a battleground, a place of ruthless competition. But here, in this unusual partnership, we see a subtler truth. Survival can emerge from cooperation, even among the most unlikely companions. Yet not all interactions are beneficial. Alongside cleaner fish and seabirds, predators lurk, patient and calculating. Sharks and orcas patrol the same waters, scanning for opportunity. And then there are humans, an unpredictable force, often unintentional but devastating. Drifting nets, pollution, and chemical changes in the water threaten the sunfish in ways evolution never prepared it for. A giant of the ocean, majestic and alien, becomes vulnerable not to natural predators, but to human activity. Despite these dangers, the sunfish moves forward, a silent traveler, guided by instincts honed over millennia. Its companions, both friends and foes, shape its journey. Each interaction is a small chapter in the story of survival. Each encounter leaves a mark, visible or unseen, on this living enigma. Observing a sunfish in this context is humbling. One moment it is an immense, almost otherworldly creature, drifting slowly through sun-dappled waters. The next, it is a stage for a miniature drama, a dance of birds, fish, and parasites, each performing their roles in an intricate balance. This duality between scale and intimacy is one of the sunfish's defining traits.
It is both solitary and central to a network of life, moving through the ocean in a way few other creatures can. Even the sunfish's skin tells a story. Beneath its rough, thick surface lie scars and marks from countless encounters. Some are evidence of predator attacks narrowly survived. Others hinted collisions with floating debris or struggles with parasites. Each mark is a record, etched into a living canvas, of the challenges it has faced. And yet, despite all the evidence of struggle, the sunfish continues. It drifts, persistent. It survives, resilient.
But there is another layer to this story, hidden beneath the surface. The sunfish's life is not just shaped by external forces. It is shaped by the ocean itself, the currents, the temperature gradients, the invisible flows that guide its movements. The sunfish responds to these forces in ways we are only beginning to understand. It senses patterns, reacts to subtle changes, navigates vast distances with astonishing precision. In a world without landmarks, without maps, it moves as though the ocean itself whispers directions. And somewhere along this journey, the sunfish encounters other giants of its kind. Not always in groups, but sometimes in fleeting assemblies where multiple sunfish drift together. These gatherings are brief, they are silent, they are enigmatic. Scientists still debate their purpose. Are they social, opportunistic, simply coincidental? Whatever the reason, these moments remind us that even solitary travelers sometimes converge, hinting at a deeper rhythm within the ocean's pulse. From the microscopic larva to the massive adult, the ocean sunfish exemplifies endurance, adaptation, and unexpected connections. It lives in extremes, moving between surface warmth and deep cold, vulnerability and dominance, solitude and symbiosis. It reminds us that the ocean is full of mysteries, and that sometimes the most extraordinary creatures are not the fastest nor the fiercest, but those that survive in the most unusual ways. In the next chapter, we will journey with the sunfish across entire oceans. We will follow it as it drifts through currents spanning thousands of kilometers, encountering new ecosystems, facing unseen dangers, and revealing behaviors that have puzzled scientists for decades. Because the true story of the ocean sunfish is not just about survival, it is about exploration, endurance, and the silent poetry of life in the deep.
The ocean is never still. Even on calm days, beneath the surface, vast rivers of water flow silently, carrying warmth, nutrients, and life across thousands of kilometers. For the ocean sunfish, these currents are both highway and home. They shape its journey, determine its meals, and subtly guide its movements. Unlike most fish, the sunfish does not rely on bursts of speed to hunt or escape. Instead, it drifts with the currents, a colossal mariner of the open sea, carried along invisible highways that link distant ecosystems. Tracking studies have revealed astonishing patterns. Sunfish have been observed traveling across entire ocean basins, moving from tropical regions to temperate waters, sometimes covering distances greater than 5,000 kilometers in a single season. How does it navigate such vast expanses, with no landmarks, no coastline, no familiar reference points? Scientists believe a combination of cues may guide it: the subtle pull of Earth's magnetic field, temperature gradients in the water, and chemical traces carried by currents. Each tiny signal acts like a whisper, directing the sunfish through a world where humans would become hopelessly lost. During these migrations, the sunfish encounters a kaleidoscope of life: schools of small fish, swarms of jellyfish, drifting plankton, and even encounters with predators all converge on its path. Yet it moves with a strange confidence. Its massive body cuts through water with a rhythm all its own, rising and descending in slow, deliberate motions, navigating between layers of differing temperatures and light levels. It is a dance refined by evolution, a combination of instinct, persistence, and adaptation honed over millions of years. But these migrations are not without risk. Floating debris and human activity have transformed large swaths of the ocean into treacherous zones. Plastic bags, fishing nets, and abandoned gear drift silently, almost indistinguishable from the sunfish's gelatinous prey.
A single misstep can be fatal. One swallowed piece of plastic, one entangled fin, can threaten the survival of a creature that has already endured countless natural dangers. And yet, somehow, many survive. The sunfish's resilience is remarkable. Despite its unusual shape, its reliance on drifting, and its delicate diet, it continues to navigate a changing ocean. Each successful journey across thousands of kilometers tells a story of endurance. Every surface bask, every deep dive, every subtle interaction with other marine life is a chapter in an epic saga that humans are only beginning to comprehend.
During these travels, patterns emerge that are almost mesmerizing. The sunfish often synchronizes its movements with the rise and fall of the sun, drifting near the surface during daylight to warm its muscles, and descend into colder, deeper waters at night to forage. It is a rhythm both predictable and mysterious, a life lived in harmony with the ocean itself. And sometimes, in the most unexpected places, the sunfish finds company. Other sunfish, dolphins, or even curious sea turtles may cross paths. These encounters are usually brief, but they offer glimpses into a hidden social world that remains largely unstudied. Do they communicate? Do they recognize each other? Do they share knowledge about currents or feeding grounds? The ocean keeps these answers hidden, leaving scientists and observers to piece together the puzzle from fleeting observations. One of the most extraordinary aspects of these migrations is the sunfish's ability to traverse such vast and varied habitats without significant harm. From the warm, sunlit surface of tropical seas to the dim, chilly depths of temperate zones, it adapts. Its body temperature fluctuates, its metabolism adjusts, and its slow, methodical movements conserve energy while still allowing it to hunt, avoid predators, and survive. It is a masterclass in evolutionary design, one that prioritizes endurance and adaptability over speed or aggression. And yet, despite all its adaptations, the sunfish remains vulnerable. Predators like large sharks and orcas still pose a threat, especially to younger or smaller individuals. Their unique shape, so advantageous for drifting, can become a disadvantage when faced with calculated attacks. Humans, however, represent a far greater, often invisible threat. Fisheries, climate change, and pollution create hazards that evolution has never accounted for. The same vast distances that allow the sunfish to find food and mates also expose it to hazards that span entire ocean basins. Still, it endures. It continues to drift, navigate, and survive in a world that is increasingly unpredictable. Every migration is a testament to resilience, to adaptability, and to the silent poetry of life in the open ocean. And perhaps the most remarkable lesson of all is how the sunfish thrives through balance. It balances depth and surface, vulnerability and strength, isolation and interaction. It drifts alone, yet influences countless other organisms. It moves slowly, yet covers incredible distances. It consumes the ocean's smallest prey, yet becomes one of the largest bony fish on Earth. Through this delicate equilibrium, it survives where many others cannot. In the next chapter, we will explore the sunfish's interactions with its environment in greater detail. We will see how it affects the ecosystems it travels through, how it interacts with other species, and how its unusual existence has ripple effects across the oceans. Because understanding the ocean sunfish is not just about observing a single species, it is about glimpsing the hidden connections that sustain life in the vast, mysterious blue. The ocean sunfish is more than a solitary traveler. It is a moving force within its environment. Despite its unusual shape and slow movements, it plays a critical role in the delicate balance of the ecosystems it traverses. Every feeding, every drift, every surface bask has consequences far beyond what we can immediately see. Take its diet, for instance. Jellyfish and other gelatinous creatures form the majority of its meals. At first glance, these soft-bodied organisms might seem inconsequential, mere drifters in the vast ocean. Yet jellyfish populations can explode, creating imbalances that ripple through entire marine communities. By feeding on them, the sunfish helps regulate these populations, indirectly supporting species that rely on plankton or small fish for survival. In a strange way, the sunfish acts as a stabilizer, a guardian of equilibrium in a world that often seems chaotic. And then there is its physical presence. A fully grown sunfish drifting slowly through the open water is like a moving reef.
Its massive body attracts cleaner fish, parasites, and even scavengers. Birds and fish descend to feed or clean, creating many ecosystems that would not exist without this giant. Even in death, the sunfish continues to shape its surroundings. Its enormous carcass, sinking to the ocean floor, becomes a temporary island of life. Deep-sea scavengers swarm, nutrients are released, and a cascade of activity unfolds around what was once a drifting giant. Yet, despite this profound influence, the sunfish remains largely mysterious. Its patterns of movement, its choice of habitat, its interaction with other species, all are subjects of ongoing research. Scientists tag individuals, track them across oceans, and gather data on temperature preferences, depth, and migration routes. And still, many questions remain. Why do some sunfish undertake longer migrations than others? How do they select specific currents or feeding areas? What unseen environmental cues guide their behavior? Each answer reveals yet another layer of complexity, a new facet of life that humans are only beginning to grasp. Perhaps what makes the sunfish truly remarkable is its embodiment of paradox. It is both massive and fragile, solitary yet central to a network of interactions, slow yet capable of traveling thousands of kilometers. Its body seems awkward yet perfectly adapted for a life of endurance rather than speed. Through this paradox, it survives, thrives even. And yet, its survival is increasingly precarious. The modern ocean is not the same as the one in which the sunfish evolved. Currents shift unpredictably, food availability changes, and human impact creates hazards that evolution could never have anticipated. Fishing nets, floating plastics, and climate-induced changes in water temperature all pose threats. Ingested debris can cause illness or death. Entanglement can immobilize the largest of sunfish. Even subtle changes in prey distribution can force them into unfamiliar or dangerous areas.
Despite these challenges, the sunfish endures. Its slow, deliberate lifestyle, its unique anatomy, and its deep evolutionary adaptations allow it to survive where many other creatures might fail. Every day, it drifts across vast distances, interacting with countless organisms, influencing ecosystems, and leaving an invisible trace on the ocean. And yet, its story is not only one of survival. It is a story of wonder, of curiosity, and of the quiet mysteries that remain hidden beneath the waves. Observers often describe the first time they see a sunfish as surreal. It rises from the depths, enormous and almost alien, sunlight glinting off its irregular body. Dorsal and anal fins rhythmically propel it upward, while its stubby clavus trails behind. Birds land delicately on its back. Cleaner fish dart about. Tiny parasites cling to its skin. It is a living tableau, a snapshot of survival, adaptation, and interconnection. And for every scientist who studies it, every filmmaker who documents it, and every casual observer who glimpses it in open water, the sunfish leaves the same impression. Life is stranger than we often imagine. The ocean sunfish, in all its awkward beauty, reminds us that evolution does not always favor what we expect, that survival is not always about speed or strength, that even the most unusual forms can thrive if they are persistent, adaptable, and connected to the rhythms of their world. In the next chapter, we will delve deeper into one of the ocean sunfish's most enigmatic behaviors, its interactions with humans. From accidental encounters in fishing nets to conservation efforts and research projects, the relationship between this giant and our species reveals both danger and hope. Because the story of the ocean sunfish is not just a tale of survival, it is a mirror reflecting our impact on the oceans and the fragile, astonishing life they sustain.
For centuries, the ocean sunfish remained largely hidden from human eyes. Its slow, drifting lifestyle and preference for open ocean made it elusive, almost ghost-like. Sailors occasionally reported strange, flat-bodied creatures near the surface, floating lazily under the sun, but these encounters were rare and often dismissed as exaggeration or myth. Today, however, the story has changed. With the advent of modern fishing, global shipping routes, and ocean exploration, humans have begun to intersect with the sunfish's world more frequently, and often unintentionally. One of the most pressing threats comes from bycatch. Sunfish are not targeted commercially, yet their immense size and drifting habits make them prone to entanglement. Longline fisheries, drift nets, and trawlers sometimes capture these giants by accident. Once trapped, their immense weight and irregular shape can prevent escape, leading to drowning or injury. Reports of sunfish washed ashore with nets still attached are heartbreaking reminders of their vulnerability. Despite their evolutionary adaptations, they are ill-equipped to deal with human-made hazards. But encounters are not always fatal. Marine researchers and conservationists have made remarkable strides in understanding sunfish behavior through tagging and tracking programs. Satellite tags provide real-time data on migration routes, dive patterns, and habitat preferences. These programs have revealed behaviors previously unknown, such as extended deep dives, seasonal movements across entire ocean basins, and interactions with other species. Filmmakers and wildlife enthusiasts now also contribute to knowledge, capturing footage that highlights the sunfish's bizarre elegance and mysterious presence in open waters. Interestingly, the sunfish's interactions with humans can sometimes be beneficial. Some coastal communities, fascinated by their enormous size and unusual shape, treat sightings as tourist attractions, promoting ecotourism initiatives. Observers document behavior, educate the public, and advocate for protection measures. Yet this proximity comes with challenges. Approaching boats can stress the sunfish, causing it to flee or submerge abruptly. In some cases, collisions have led to injuries, reminding us that even well-intentioned observation can be dangerous for these gentle giants. Humans also inadvertently shape the sunfish's ecosystems. Pollution, particularly plastic waste, can confuse the sunfish into ingesting harmful debris, mistaking floating bags or packaging for jellyfish. Chemical runoff alters water quality, impacting the availability of prey. Overfishing of other species indirectly affects the sunfish by changing the dynamics of ocean food webs. Every human action, direct or indirect, has consequences for this delicate traveler. Conservation efforts are beginning to address these challenges. Marine protected areas have been established in some regions to safeguard migration routes and feeding grounds. Awareness campaigns encourage fishermen to modify practices, reducing accidental capture and promoting safer handling when encounters occur. Researchers continue to study the sunfish's life cycle, feeding habits, and environmental interactions to better understand how to protect them. Yet the vastness of the ocean means there is still much we do not know. Despite the risks, the sunfish endures, drifting with quiet persistence. Its enormous presence, bizarre shape, and slow, deliberate movements remind us of the ocean's mysteries. Each encounter, whether fleeting or fatal, teaches us about resilience, adaptation, and the interconnectedness of life. But the story does not end with survival. The sunfish is also a window into broader ecological systems, a lens through which we can observe the subtle balances of life in the ocean. Its existence highlights relationships between predator and prey, parasite and host, surface and depth, human and wildlife. It challenges our assumptions about what survival looks like. It demonstrates that strength comes not only from power or aggression, but from endurance, adaptation, and the ability to coexist within a complex web of life. And as we study it, we begin to reflect on our own role in the oceans. The presence of humans has altered the sunfish's world, yet it also provides opportunities for protection, understanding, and awareness. Each decision we make about fishing practices, pollution, and conservation has the potential to shape the future of these giants. In the next chapter, we will explore the sunfish's mysterious reproductive habits, one of the most astonishing aspects of its life. We will follow its incredible capacity to produce hundreds of millions of eggs, witness the perilous journey of the larvae, and uncover the evolutionary strategies that allow this giant to persist across millennia. Because to truly understand the ocean sunfish, we must witness not only its survival, but its extraordinary ability to give life.
The ocean sunfish is a giant of the seas, yet its journey truly begins with the smallest of beginnings, the egg. A single female sunfish has the capacity to release up to 300 million eggs at once, more than any other known vertebrate on Earth. Each tiny, translucent sphere carries within it the potential for life, a delicate spark capable of growing into a creature that can weigh over a ton. the process of reproduction is both astonishing and perilous. Sunfish gather in certain regions during the breeding season, often in subtropical or temperate waters where conditions are favorable. Courtship is subtle, almost imperceptible. Males and females swim in proximity, releasing eggs and sperm into the water column simultaneously. Fertilization occurs externally, and then the cycle of chance begins. From hundreds of millions of eggs, only a minuscule fraction will survive. Turrets sweep most away, predators consume countless others, and environmental hazards claim yet more. The larvae that survive are barely recognizable. No larger than a grain of rice, they possess spines and an armored appearance that makes them strikingly different from the adult sunfish. Their world is a dangerous one. Planktonic predators, shifts in temperature, and ocean turbulence all threaten their survival. Yet even in these early stages, the sunfish demonstrates a remarkable evolutionary strategy: quantity over quality. By producing an astronomical number of eggs, it ensures that at least a few will reach maturity. Growth is rapid but perilous. Within weeks, the tiny larvae begin to transform. Spines shrink, the body begins to flatten, and the beak-like mouth takes shape. Each development stage brings new advantages and new vulnerabilities. The open ocean is a place where only those who adapt survive. By the time a sunfish reaches a size of a few centimeters, it is already navigating a world of predators, currents, and scarce food. Its slow, deliberate movements and gelatinous diet help it survive, but every moment remains fraught with risk. Even at juvenile stages, the sunfish is a paradox. It is large enough to deter some predators, yet small enough to be easily targeted by others. Its diet of jellyfish and soft-bodied creatures, though efficient for growth, provides minimal energy, forcing it to spend much of its time foraging. And still, it persists. This relentless drive towards survival is echoed throughout the species. As the sunfish grows, its body begins to assume the iconic flattened shape that makes it instantly recognizable. Its stubby tail, the clavus, emerges. Its dorsal and anal fins extend, allowing its distinctive flapping movement. And slowly it transitions from a vulnerable juvenile into a massive, drifting giant of the ocean.
Yet even as it becomes a creature of immense size, reproduction remains at the heart of its survival strategy. Unlike many species that reproduce once or a few times, the sunfish has the potential for repeated spawning events over several years. Each spawning season represents an opportunity to perpetuate the species, even in the face of a dangerous and unpredictable environment. And while we often marvel at the sunfish's size and bizarre form, it is this reproductive capacity that truly ensures its presence in the oceans. Without it, the species would vanish long before reaching the surface or drifting across thousands of kilometers of open water. Evolution has armed the sunfish with an extraordinary ability to create life, a capacity that balances its many vulnerabilities and allows it to persist as one of the ocean's most unusual giants. But reproduction is only one part of the story. The journey from egg to adult is a testament not just to survival, but to adaptation, resilience, and the hidden strategies of life beneath the waves. Every stage, from microscopic larva to enormous adult, is a dance with chance. Currents, predators, temperature, and food availability all play a role. And yet, despite these obstacles, the species endures, drifting, growing, and reproducing with a persistence that borders on the miraculous. In the next chapter, we will explore the mysterious behaviors of the adult sunfish, the deep dives, the sunbathing, and the unexplained patterns that have puzzled scientists for decades. We will witness how these giants interact with their environment in ways that are both subtle and profound, revealing a creature as enigmatic as it is massive.
As the ocean sunfish reaches adulthood, its life becomes a delicate balance of survival, feeding, and navigating the vast, unpredictable ocean. Its enormous size brings strength, but also unique challenges. Its unusual shape, once a liability as a juvenile, now allows it to drift effortlessly through the water, conserving energy over long distances. Yet, despite decades of research, much about the sunfish's adult behavior remains enigmatic. One of the most striking behaviors is its vertical migration.
Sunfish are not confined to a single depth. They traverse hundreds of meters of water daily, moving from warm surface waters to the cooler, darker depths below. During the day, many descend into the cold, deeper layers of the ocean, hunting for jellyfish, salps, and other soft-bodied organisms that populate these zones. At night, or when temperatures drop, they rise back toward the sunlit surface, basking to regulate their body temperature and restore energy. This rhythm of movement, repeated day after day, suggests a highly evolved adaptation to a challenging environment. But the precise mechanisms guiding these migrations remain a mystery. Do sunfish navigate by temperature cues, by magnetic fields, by subtle chemical signals carried on ocean currents? Scientists are still investigating. Another fascinating behavior is their sunbathing at the ocean surface. Floating on their sides, sometimes motionless for hours, sunfish appear almost as sculptures, suspended between water and sky. For centuries, sailors assumed these were dying fish, too weak to move. In reality, this behavior serves multiple purposes. Thermoregulation. After deep, cold dives, basking in sunlight helps the sunfish recover. Parasite control. Cleaner fish and seabirds take advantage of the giant's passive posture, removing parasites from its skin. Observation and rest. By remaining near the surface, the sunfish may be able to monitor its environment while conserving energy. This combination of survival strategies is subtle yet profound, illustrating how evolution has shaped even the strangest forms of life into effective, adaptive organisms. Sunfish also demonstrate unexpected social interactions. Although largely solitary, adult sunfish occasionally gather with others, sometimes forming loose aggregations in productive feeding areas. These encounters are brief and mysterious. Observers have documented instances where multiple individuals float together near the surface, occasionally interacting with one another, yet rarely displaying overt social behaviors. The reasons behind these gatherings remain unclear. Are they coordinated for feeding efficiency, for mating opportunities, or are they coincidental, dictated by currents and prey abundance? Each observation adds pieces to a puzzle that continues to challenge marine biologists. Despite their size, adult sunfish are vulnerable to predators. Large sharks and orcas have been documented preying on them. Their unusual shape, while advantageous for drifting and thermoregulation, can be a disadvantage when faced with predators capable of calculated attacks. A well-coordinated predator can flip or immobilize a sunfish, exposing its softer underbelly. Humans add an entirely different layer of threat. Bycatch, vessel strikes, and pollution now pose challenges that evolution did not prepare them for. Even the most massive and bizarre creature can be fragile when confronted with industrial-scale hazards. Yet resilience defines the sunfish. Its adaptations, slow, energy-efficient movement, a diet of abundant jellyfish, and its unique reproductive strategies allow it to persist where many others fail. Its behavior reflects both vulnerability and ingenuity, a living testament to the balance between risk and reward in the natural world. Perhaps the most mysterious aspect of adult behavior lies in long-distance migrations. Some individuals have been tracked crossing thousands of kilometers, moving between oceans, following currents, and navigating waters that vary dramatically in temperature, depth, and prey availability. These migrations reveal an extraordinary ability to survive and adapt to changing conditions, but they also raise profound questions. How does the sunfish know where to go? What guides its path across the vast, featureless expanse of the open ocean? Are there subtle environmental cues invisible to humans that direct its movements? The answers remain largely elusive.
And so, the adult ocean sunfish remains a paradox, a drifting giant, graceful yet awkward, solitary yet connected to countless other organisms, a predator and a host, vulnerable and resilient. Its life is an ongoing dance with the ocean, a rhythm shaped by instinct, opportunity, and the subtle forces of a world humans are only beginning to understand. In the next chapter, we will delve into the ecological impact of the sunfish, exploring how its presence shapes the food web, influences populations of jellyfish and other prey, and contributes to the balance of marine ecosystems. Because to understand the ocean sunfish fully, we must see it not only as a creature of curiosity and wonder, but as a vital participant in the health of the oceans. The ocean sunfish is not just a curiosity, it is an integral part of the ocean's intricate web of life. Its influence stretches far beyond its massive drifting form, shaping the ecosystems it inhabits in ways that are both subtle and profound.
By feeding primarily on jellyfish, the sunfish performs a critical ecological role. Jellyfish are abundant, resilient, and capable of reproducing rapidly. In the absence of predators like the sunfish, their populations can explode, consuming plankton and competing with small fish that humans and other predators rely upon. By keeping jellyfish numbers in check, sunfish help maintain balance within the marine food web. In this way, the sunfish is a regulator, quietly ensuring that the ocean's delicate equilibrium persists. Its massive body also serves as a mobile ecosystem. Parasites, cleaner fish, and seabirds interact with the sunfish, creating microhabitats on its surface. These interactions benefit the smaller species by providing food and shelter, while simultaneously benefiting the sunfish by removing harmful parasites. Even after death, the sunfish contributes to the ecosystem. When its carcass sinks to the deep ocean floor, it becomes a temporary island of life. Scavengers swarm, nutrients are released, and the remains support an entire cascade of organisms that rely on this sudden influx of sustenance. The sunfish also connects disparate parts of the ocean. Through its migrations, it carries nutrients and energy across vast distances. Its movements link tropical, subtropical, and temperate waters, connecting food webs that would otherwise remain isolated. In a sense, each sunfish acts as a living bridge, distributing biological influence across thousands of kilometers. But its ecological role is not limited to prey and parasites. By participating in surface cleaning interactions, the sunfish creates opportunities for smaller species to thrive. Birds and fish that rely on these temporary cleaning stations can feed safely, reproducing and contributing to the health of their populations. The sunfish becomes more than a predator. It becomes a facilitator of life. And yet all of these ecological contributions exist within a fragile balance. Environmental changes, human activity, and climate shifts threaten the systems the sunfish depends upon. Jellyfish populations fluctuate with temperature and nutrient availability. Human pollution can introduce toxins, and bycatch continues to remove large individuals from the population. Disrupt one component, and the ripple effects can be dramatic. This fragility highlights the sunfish's resilience. Despite the odds, the species persists. Its reproductive strategy, massive size, and unique adaptations allow it to survive in a world filled with both natural and human-imposed challenges. The sunfish teaches a profound lesson that even the most unusual and seemingly awkward creatures can play a critical role in sustaining life. Ecologists now recognize the ocean sunfish as more than a bizarre giant. It is a key indicator species. Its health reflects the state of the ecosystem around it. Changes in migration patterns, reproductive success, or feeding behavior can signal shifts in ocean health that might otherwise go unnoticed. In many ways, the sunfish is a silent sentinel, moving through the open ocean and revealing the invisible threads that hold marine ecosystems together.
And for every observer, scientist, or diver fortunate enough to witness it, the sunfish serves as a reminder. The ocean is full of mysteries, and even the strangest forms of life can hold profound significance. Its life, from microscopic egg to drifting giant, embodies survival, adaptation, and the subtle interconnections that define our planet's waters. In the next chapter, we will explore the incredible journeys of sunfish across the globe, tracking their migrations, encounters, and the hidden strategies that allow them to thrive in the vast, ever-changing oceans. Because understanding the ocean sunfish is also a journey into the heart of the ocean itself. The ocean sunfish is a wanderer without equal. Its migrations span oceans, crossing thousands of kilometers in search of food, suitable temperatures, and breeding grounds. Unlike many marine animals that rely on speed or strength, the sunfish moves with patient persistence, drifting with currents, tropical waters near Japan, all the way to temperate zones near California. Others in the Atlantic migrate between the Canary Islands and the coast of Portugal, navigating vast, featureless waters with remarkable consistency. How a creature so massive, yet seemingly clumsy, achieves such precision is still a mystery. Researchers hypothesize a combination of environmental cues, temperature gradients, salinity changes, magnetic fields, and chemical signatures carried on currents. These subtle signals guide the sunfish as surely as any map or compass. During these migrations, the sunfish encounters a diverse array of ecosystems. From jellyfish blooms near the surface to the twilight zone hundreds of meters deep, it moves through environments with vastly different conditions. Each layer presents new opportunities and challenges: predators, food sources, temperature shifts, and ocean currents. The sunfish adapts seamlessly, conserving energy through slow, deliberate movements and feeding efficiently on abundant, soft-bodied prey. Interestingly, not all sunfish travel alone. Occasionally, researchers have observed multiple individuals converging in regions rich with jellyfish or other prey. These gatherings are brief and fluid, with no clear social hierarchy. Unlike schooling fish, sunfish maintain loose proximity, each following its own path, yet benefiting indirectly from the presence of others. These transient aggregations highlight the subtle complexity of their behavior, revealing that even solitary giants occasionally form ephemeral networks within the vast ocean. Predation remains a constant factor during these journeys. Sharks and orcas patrol these waters, and while few predators are large enough to tackle a full-grown sunfish, juvenile and mid-sized individuals remain vulnerable. Encounters are often quick, dramatic, and sometimes fatal, emphasizing that even giants must navigate a world filled with threats. Human activity also intersects with these migrations. Shipping lanes, fishing operations, and floating debris create hazards. Plastic waste, mistaken for jellyfish, poses particular danger, highlighting the delicate balance between survival and risk in the modern ocean.
Yet, the ocean sunfish endures. Its migrations are not random. They follow rhythms that align with prey availability, temperature preferences, and possibly reproductive cycles. These journeys are a testament to endurance, patience, and the evolutionary wisdom encoded within its behavior. The sunfish's global travels also reveal its ecological influence. By moving across oceans, it connects distant ecosystems, transferring energy and nutrients through its feeding and eventual waste. It affects jellyfish populations across broad regions and provides temporary habitats for cleaner fish and seabirds along the way. Even its carcass, sinking after death, nourishes deep-sea communities thousands of kilometers from where it once lived. Through these journeys, the sunfish becomes more than a singular creature. It becomes a traveling node in a vast interconnected system. Each migration, each feeding event, each interaction with other species contributes to the health and stability of the ocean at a scale humans are only beginning to comprehend. Despite its odd appearance and slow movements, the sunfish exemplifies resilience, adaptability, and subtle influence. Its life is a study in persistence, showing that survival depends not only on speed or aggression, but on understanding and navigating complex relationships with the environment. In the next chapter, we will explore the hidden mysteries of the sunfish's deep dives, the abyssal excursions that take it hundreds of meters below the surface, into a world of darkness, cold, and strange life forms. Because the ocean sunfish is not just a surface drifter, it is an explorer of depths few creatures dare to traverse.
While much of the ocean sunfish's life is spent drifting near the surface, it is no stranger to the dark, cold depths. Deep dives are a regular part of its behavior, taking it hundreds of meters below sunlight into a realm few human eyes have seen. These deep excursions serve multiple purposes. First, feeding. Many of the sunfish's prey, jellyfish, salps, and siphonophores, dwell at varying depths, often moving vertically throughout the day. By diving, the sunfish accesses a broader range of food sources, exploiting prey that remains hidden from surface dwellers.
These deep journeys remain one of the great mysteries of marine biology. Do they follow prey, avoid predators, orient themselves using magnetic fields? Or is there a behavioral component we have yet to understand? Each dive adds new data, yet the purpose of many excursions remains speculative. What is certain is that these movements illustrate the sunfish's extraordinary adaptability. It is a creature of contrasts, surface drifter and deep explorer, slow and enduring, vulnerable yet resilient.
Its life spans zones of extreme conditions, balancing energy efficiency with the demands of feeding, survival, and reproduction. The ocean sunfish reminds us that survival in the ocean is rarely simple. It requires patience, adaptation, and the ability to navigate multiple challenges simultaneously. Its deep dives are not merely excursions. They are demonstrations of endurance, balance, and the extraordinary strategies life can evolve in the open sea. In the next chapter, we will examine the sunfish's interactions with other marine giants, sharks, whales, and other large predators, and how these encounters shape its life and behavior. Because in the ocean, even a drifting giant cannot exist in isolation.
The ocean sunfish, for all its size and peculiar shape, shares the ocean with other formidable creatures. From great sharks to massive whales, the sunfish coexists with some of the largest and most powerful animals on Earth. These encounters are rare but profound, revealing the delicate balance of risk and survival in the open ocean. Predation is one of the sunfish's constant challenges. Large sharks, including the great white and the Tiger shark, are capable of attacking sunfish, particularly juveniles or mid-sized individuals. Observations have documented scars and bite marks on adult sunfish, evidence of near misses and survival in the face of danger. Unlike fast or agile prey, the sunfish relies on size and unpredictability to survive. Its enormous body, awkward shape, and vertical movement patterns make attacks difficult for predators to execute. Yet, no strategy is foolproof. The ocean is an arena of constant challenge. Interactions with whales are more curious than dangerous. Some whales, particularly baleen species, share feeding grounds with sunfish. While whales pose no direct threat, their movements stir up prey and create shifting dynamics in the water column. Sunfish can benefit from these disturbances, accessing food more easily in the wake of larger creatures. Occasionally, sunfish have been observed near pods of dolphins, seemingly undisturbed by the playful presence of these intelligent mammals. While the reasons for these encounters remain unclear, they highlight the sunfish's role as a participant in a complex network of ocean life. Even other sunfish sometimes intersect in these waters. Aggregations, though not highly social, occur in regions of abundant food. These gatherings can appear almost like drifting, floating islands where several giants float in close proximity. While they do not exhibit schooling behavior, their presence affects predator strategies, cleaning patterns, and even the distribution of smaller organisms. In all these interactions, the sunfish demonstrates a combination of resilience and adaptability. Its unusual body, flat, wide, and nearly circular, is not designed for speed or attack, yet it persists. Its lifestyle is slow, deliberate, and calculated. It survives not through dominance, but through endurance, camouflage, and the subtle strategies evolution has provided. Human interaction adds a new dimension. Vessels, fishing operations, and recreational boats share the same waters. Although sunfish are not aggressive, collisions can occur, leading to injury or death. Conservationists emphasize the need for awareness, monitoring, and protective measures to ensure these giants continue to roam freely. And yet, despite all challenges, the sunfish remains an icon of the ocean's mystery. It drifts alongside the giants of the seas, indifferent to much of what surrounds it, yet fully integrated into the network of life. Its presence affects predators, prey, and smaller species alike. Each encounter tells a story of survival, coexistence, and the subtle power of adaptation. Through these interactions, the sunfish teaches a remarkable lesson. Survival is not always about strength or speed. Sometimes it is about persistence, patience, and the ability to navigate a world filled with dangers and opportunities. In the vast, unpredictable ocean, even the most unusual creatures can thrive if they master the art of balance.
In the next chapter, we will explore the sunfish's mysterious communication and sensory abilities, how it perceives the world around it, navigates vast distances, and senses the invisible cues that guide its extraordinary life. Because the ocean sunfish is not only a giant, it is a sophisticated navigator of the ocean's hidden rhythms.
The ocean sunfish, for all its immense size and peculiar shape, exists in a world that is largely invisible to humans. Unlike terrestrial animals that navigate by sight, smell, and sound within a limited three-dimensional space, the sunfish drifts through the vast three-dimensional ocean, a realm of currents, temperature gradients, and chemical signals that humans can barely perceive. How does it survive here? How does it know where to feed, where to avoid danger, and where to breed? The answers lie in its extraordinary sensory and navigational abilities, honed by millions of years of evolution. Unlike many predatory fish, the sunfish does not rely on aggressive hunting or high-speed chases. Its diet consists largely of jellyfish, salps, and other gelatinous plankton, food sources that drift slowly through the water column. To find these prey, the sunfish must detect subtle cues, changes in water density, temperature, and chemical signals that indicate the presence of swarms or blooms. Each encounter is a delicate exercise in perception. Chemical sensing is a primary tool. The sunfish has highly sensitive olfactory organs, capable of detecting molecules released by jellyfish and other prey. This chemical map of the ocean allows the sunfish to move towards areas of high food concentration. Unlike humans who rely on sight to identify food, the sunfish essentially smells the ocean. Its environment is a complex tapestry of invisible chemical trails, drifting currents, and minute signals, all of which it can detect with astonishing precision. Yet chemistry is only part of the story. The sunfish is also a master of thermoregulation and temperature sensing. As it migrates vertically through the water column, it encounters layers of varying temperatures, known as thermoclines. Warm surface waters provide energy for basking and recovery, while cooler depths often harbor prey and offer relative safety from predators. By sensing subtle temperature differences, the sunfish can navigate between these layers, optimizing energy expenditure while maximizing food intake. These thermal migrations are not random. Studies show patterns that suggest remarkable consistency. Sunfish will dive hundreds of meters during the day, returning to warmer surface waters at night. The timing, depth, and duration of these dives appear finely tuned to environmental cues, prey availability, and possibly even lunar cycles. Yet the exact mechanisms that guide these movements remain elusive, leaving scientists in awe of the sunfish's invisible navigational system. The sunfish's visual system also plays a critical role, but in a way that differs from many other predators. Its large, forward-facing eyes are adapted to low light conditions, allowing it to detect prey and predators both near the surface and at depth. In the dimly lit twilight zone, hundreds of meters below the sunlit surface, this visual acuity becomes essential. The sunfish does not need the speed or precision of a shark. It simply needs to detect and intercept slow-moving prey while avoiding predators that may lurk in the shadows. In addition to sight, there is growing evidence that sunfish may sense magnetic fields, a trait shared by many migratory marine species. This ability could explain how individuals navigate thousands of kilometers across open oceans with remarkable accuracy. In a world devoid of landmarks, magnetic orientation may act as an internal compass, allowing sunfish to follow seasonal migration routes, locate feeding grounds, and even return to specific breeding areas.
Yet perception is not limited to individual survival. The sunfish also interacts with an entire community of organisms in ways that require constant awareness. Cleaner fish, parasites, and seabirds all rely on the sunfish's presence. Its thick, sometimes scarred skin provides habitat for smaller creatures, creating micro-ecosystems on its back. Each interaction is a complex negotiation. A cleaner fish removes parasites, gaining food in exchange, while the sunfish gains relief. Birds hovering above perform similar services, plucking parasites from its surface. These interactions require subtle coordination. The sunfish must remain sufficiently still to allow cleaning, yet retain the ability to flee from predators or environmental hazards at a moment's notice. Its ability to sense movement, vibration, and chemical cues in the water enables it to balance these competing needs. Communication within the species remains largely mysterious. Sunfish are not known to vocalize, yet observations suggest they may use body orientation, movement, and even subtle water vibrations to convey information. Brief aggregations in feeding zones or during migrations hint at awareness of other individuals. These meetings are fleeting, almost ghost-like, yet they suggest that sunfish are far from passive drifters. They are keenly attuned to the movements of other creatures, both giant and microscopic, in their environment. The sunfish's sensory abilities also intersect with its reproductive behavior.
During spawning, females release hundreds of millions of eggs, often in areas selected for optimal conditions: water temperature, salinity, and prey abundance.
In essence, the ocean sunfish exemplifies a paradox of marine life, a giant that drifts slowly across the ocean yet perceives it with extraordinary acuity. Its sensory world is invisible to humans, a hidden dimension of chemical, thermal, magnetic, and vibrational cues that dictate movement, feeding, and reproduction. Each dive, each drift, and each interaction reflects a sophisticated understanding of the ocean's rhythms. The sunfish teaches us that survival in the ocean is as much about perception as it is about size or speed. It reminds us that even the most unusual creatures can master the invisible forces around them, turning vulnerability into endurance, isolation into integration, and opportunity into survival. In the next chapter, we will explore the ancient origins of the ocean sunfish, tracing its evolutionary history, examining fossil records, and understanding how millions of years of adaptation have produced this floating enigma of the seas. We will uncover how its strange body plan, massive reproductive capacity, and migratory instincts are products of evolutionary pressures as unique as the creature itself. Because to truly understand the ocean sunfish, we must look not only at its behavior today, but also at the long journey through time that shaped it into the giant of the oceans.
To understand the ocean sunfish today, we must travel back millions of years, into a time when Earth's oceans were still shaping the diversity of life we now take for granted. The sunfish, strange and almost alien in appearance, did not emerge suddenly. Its evolution is a tale of adaptation, survival, and innovation across epochs of environmental change. Fossil records suggest that the sunfish's ancestors first appeared during the Eocene epoch, approximately 50 million years ago. Early relatives were far more streamlined than today's massive giants, resembling small, deep-bodied fish that could maneuver quickly in predator-rich waters. Over time, environmental pressures favored unique adaptations: open ocean habitats, scarcity of fast-moving prey, and the expansion of gelatinous organisms, such as jellyfish, created selective forces that molded the sunfish into its current form. Unlike many other predatory fish, sunfish ancestors did not evolve for speed or hunting prowess. Instead, they developed a body plan optimized for drifting, energy efficiency, and survival in a world dominated by slow-moving prey. Over millions of years, this gave rise to the distinctive flattened circular body we recognize today. The loss of a traditional tail, replaced by the clavus, a rudder-like structure, illustrates a remarkable trade-off: mobility sacrificed for stability and energy conservation. The sunfish's extraordinary reproductive strategy also has deep evolutionary roots. The ability of a single female to produce hundreds of millions of eggs is not merely biological extravagance, it is survival. In the open ocean, juvenile mortality is catastrophic. Predators, currents, and environmental variability ensure that only a tiny fraction of offspring survive. By producing enormous numbers of eggs, sunfish ancestors guaranteed that at least some would reach adulthood, perpetuating the lineage over millennia. Fossil evidence also hints at the gradual increase in size. Ancient relatives were significantly smaller than the modern sunfish. Over evolutionary time, the species grew, benefiting from fewer predators as body size increased and gelatinous prey became more abundant. Larger size also offered advantages in thermoregulation and migration. A bigger body retains heat longer, allowing the sunfish to explore cooler waters and dive to greater depths with less metabolic cost. Interestingly, the sunfish's peculiar skeletal structure reflects evolutionary compromise and innovation. Unlike most fish, it has relatively few vertebrae and an incomplete skeletal tail, relying on dorsal and anal fins for propulsion. This design is efficient for long drifting journeys, but unsuitable for rapid bursts of speed. Evolution favored endurance over agility, reflecting the demands of a world where drifting with currents and feeding on abundant, slow-moving prey became the optimal survival strategy.
The expansion of jellyfish and other gelatinous plankton during certain geological periods likely influenced sunfish evolution. While other species sought haster prey or developed more aggressive hunting strategies, the ancestors of Mola Mola embraced an energy-efficient, passive lifestyle, feeding on soft-bodied organisms that were plentiful but low in energy.
Over time, this strategy reinforced the unique combination of slow movement, massive size, and extraordinary reproductive output that defines modern sunfish. As the oceans changed, the sunfish adapted in other remarkable ways. Temperature fluctuations, shifts in ocean currents, and the appearance of new predator species all imposed evolutionary pressures. Sunfish developed the ability to migrate over long distances, adjusting depth and temperature preferences to optimize feeding and survival. Their sensory systems evolved to detect chemical cues, temperature gradients, and possibly geomagnetic fields, tools critical for navigating open waters that stretch thousands of kilometers without landmarks. Predator avoidance also shaped evolution. Sharks and orcas are capable hunters, and juvenile sunfish remain vulnerable even today. Scar patterns on modern sunfish suggest that predator interactions have long influenced morphology and behavior. Large body size, vertical movement patterns, and thick, tough skin all reflect adaptations honed over millions of years to survive in a predator-rich environment. The sunfish's evolution is also a story of ecological integration. As ocean ecosystems expanded, sunfish became vital participants. Their presence influences jellyfish populations, provides habitat for cleaner fish, and even nourishes deep-sea communities after death. Over evolutionary time, these interactions may have reinforced survival strategies, shaping behavior, migration, and reproductive output. In essence, the sunfish is not merely a drifting giant, it is an ecosystem engineer, a moving node in the complex web of ocean life. Fossils also reveal that sunfish evolution was not linear. There were periods of diversification, extinction, and morphological experimentation. Some extinct relatives had elongated fins, unusual spines, or different skeletal configurations, suggesting that the lineage explored a variety of forms before settling on the modern design. This trial and error process, occurring over tens of millions of years, highlights the flexibility and resilience of the species. The modern sunfish, Mola Mola, is therefore the culmination of millions of years of adaptation. Its flat, circular body, stubby clavus, massive size, slow movement, deep dives, long-distance migrations, and staggering reproductive capacity are all evolutionary solutions to the challenges of an open ocean lifestyle. Every quirk of its anatomy and behavior tells a story of survival, compromise, and ingenuity. Yet the evolutionary journey is ongoing. Humans have introduced new pressures, pollution, bycatch, climate change, that did not exist in the past. These modern challenges force sunfish to adapt at an unprecedented pace. The species' future will depend not only on its ancient adaptations, but also on its ability to navigate a world dramatically altered by human activity. Studying the sunfish's evolution also provides insight into the broader story of marine life. It demonstrates how species can survive through specialization, paradoxical adaptations, and subtle ecological integration. It reminds us that evolution is not always about speed, aggression, or efficiency in ways humans expect. Sometimes survival favors patience, endurance, and the ability to perceive and navigate invisible forces. In essence, the ocean sunfish is a living relic of evolutionary history, a testament to the adaptability of life in the open ocean. Its bizarre form, gentle movements, and enormous reproductive potential are products of millions of years of trial, error, and refinement. By understanding its origins, we gain perspective not only on this extraordinary creature, but also on the delicate and interconnected world of the oceans themselves. In the next chapter, we will follow the ocean sunfish in its daily life, combining all aspects of its evolution, sensory perception, migration, and ecological role. We will see how this living fossil navigates the modern ocean, interacts with other species, and survives in a world both ancient and increasingly shaped by humans.
In the next chapter, we will explore the hidden mysteries and unknowns that still surround the ocean sunfish. Despite decades of observation, tagging, and research, there are behaviors, deep-sea excursions, and ecological interactions that remain largely unexplained. We will delve into these mysteries, exploring what scientists know, what remains speculative, and why the sunfish continues to inspire awe and curiosity around the globe.
In some regions, extraordinary observations have documented sunfish aggregations. While largely solitary, sunfish sometimes gather in groups, particularly at rich feeding grounds or during spawning events. Such aggregations can include dozens of individuals of varying sizes. Observers note coordinated movements, subtle spacing adjustments, and what appears to be awareness of other individuals' positions. Though scientists cannot yet confirm complex social behavior, these aggregations suggest that sunfish are capable of temporary social coordination, a behavior previously underestimated.
Diving alongside sunfish also reveals their curiosity and interaction with humans. Reports from divers describe adult sunfish approaching closely, sometimes within a few meters, rotating slowly to observe divers or boats. Some individuals appear indifferent, while others demonstrate mild avoidance. The variability in response suggests individual temperament, previous experience, or even learned behavior. Unlike aggressive species, sunfish rarely exhibit defensive behavior toward humans, reinforcing their reputation as gentle giants of the ocean. Close-up encounters have also revealed unexpected feeding behavior. While primarily gelatinous prey consumers, sunfish have been observed feeding opportunistically on small fish, plankton, and even floating detritus. Divers report seeing sunfish adjusting orientation to capture swarms of jellyfish, using subtle rotations of the body to engulf prey efficiently. This behavior demonstrates not only energy-efficient feeding, but also the sunfish's ability to perceive and exploit small-scale environmental variations, a reminder that even slow-moving giants are finely attuned hunters in their ecological niche. Bioluminescence encounters at depth have added a new layer of mystery. Tagging studies and deep-diving submersibles have documented sunfish diving into the mesopelagic zone, where faint bioluminescent organisms drift silently. Observers note that the sunfish seems to navigate these dark waters with precision, adjusting depth and orientation without apparent visual cues. Some speculate the fish may detect bioluminescence or other subtle cues to locate prey, avoid predators, or maintain navigation. Each descent into darkness adds to the enigma of their sensory perception. Observers also report interactions with other marine megafauna. Schools of dolphins have been seen swimming alongside sunfish, sometimes brushing against their bodies in what appears to be curiosity or playful interaction. Large whales occasionally create turbulence that stirs prey, inadvertently aiding feeding opportunities for sunfish. These cross-species interactions demonstrate that sunfish exist not in isolation, but as active participants in complex oceanic networks. Every movement influences and is influenced by other organisms, reinforcing the interconnectedness of marine ecosystems. Finally, extraordinary encounters include unexpected surface phenomena. On rare occasions, sunfish have been observed breaching or partially leaping from the water, behavior not fully understood. These movements could be related to parasite removal, mating displays, or simple exploratory behavior. Regardless of the cause, such moments evoke awe, reminding observers that despite decades of study, the sunfish still retains behaviors that are largely unknown and astonishing to witness firsthand. These extraordinary encounters highlight several critical truths. The ocean sunfish, despite its size and slow appearance, is a highly perceptive and adaptable species. Its behaviors, from basking to deep dives, are carefully balanced to optimize energy, survival, and ecological interactions. Human observation, while increasing knowledge, still captures only glimpses of its full complexity. Each encounter deepens our understanding while reminding us of the vast unknowns that remain. The ocean sunfish continues to inhabit a realm of mystery, a living bridge between the familiar and the alien, the studied and the hidden. In the next chapter, Part 22, we will explore the intricate relationships between sunfish and their oceanic environment, analyzing how these gentle giants influence jellyfish populations, nutrient cycles, and the broader marine ecosystem. This exploration will reveal the sunfish's critical role in maintaining oceanic balance and highlight the ecological importance of preserving their populations.
The ocean sunfish, while often described as a drifting giant of the seas, is far more than a passive inhabitant of the ocean. Its presence has profound effects on the structure and function of marine ecosystems, influencing prey populations, supporting other species, and contributing to nutrient cycles that sustain life across vast distances. Understanding these ecological interactions reveals the sunfish not only as a unique species, but as a keystone participant in oceanic balance. One of the sunfish's most direct ecological impacts is on jellyfish populations. Feeding primarily on gelatinous organisms, sunfish help regulate the abundance of jellyfish in open waters. While each individual consumes what may seem like a modest quantity relative to its size, the cumulative effect across thousands of sunfish in oceanic regions can be substantial. By controlling jellyfish numbers, sunfish indirectly influence plankton communities and the distribution of small fish that rely on plankton as a food source. This predation helps maintain a delicate balance, preventing jellyfish blooms from overwhelming ecosystems. The sunfish also contributes to parasite management in the ocean. Cleaner fish, wrasses, and birds rely on the sunfish as a mobile feeding platform. These interactions create dynamic microecosystems, allowing smaller species to thrive. Observations reveal that certain parasites removed from sunfish may otherwise proliferate in the surrounding environment, influencing the health of other marine organisms. In this way, the sunfish serves as a hub of ecological activity, supporting biodiversity even through seemingly small-scale interactions. Vertical migrations by sunfish also play a critical role in nutrient cycling.
By diving hundreds of meters during the day and returning to the surface, sunfish transport nutrients between deep and shallow layers of the ocean. Their excretion and movement distribute organic matter, providing nourishment for plankton and other small organisms at various depths. These nutrient transfers are crucial in nutrient-poor regions of the open ocean, acting as natural fertilization that sustains productivity in otherwise sparse environments. The sunfish's interactions with other marine megafauna further illustrates its ecological importance. Schools of dolphins and other large fish may follow sunfish to exploit stirred prey or benefit from cleaning symbioses. Large whales and even sea turtles can inadvertently facilitate sunfish feeding by creating turbulence that bring gelatinous organisms closer to the surface. Through these interactions, sunfish are integrated into a complex web of mutual influence, connecting species that would otherwise interact only indirectly. Sunfish also influence ecosystem structure through their reproductive strategy. The staggering number of eggs produced by a single female, hundreds of millions in some cases, ensures that juvenile sunfish become a food source for a range of predators, including fish, seabirds, and even other sunfish. While many offspring do not survive to adulthood, their presence sustains predator populations and contributes to the broader food web. In this way, the sunfish serves as both predator and provider, shaping trophic dynamics across the ocean.
Surface basking behavior additionally impacts coastal ecosystems and human interactions. Sunfish often attract seabirds during surface intervals, providing feeding opportunities that would otherwise be limited. Coastal tourism and ecotourism centered around sunfish create educational opportunities and economic incentives for marine conservation. Observations from these interactions also inform scientific understanding, enhancing conservation strategies and fostering global awareness of the species' ecological role. In deeper waters, sunfish contribute indirectly to pelagic ecosystem health. By feeding on deep-dwelling gelatinous organisms, they regulate populations of prey that might otherwise dominate certain depths. Their movement patterns can redistribute prey and predators alike, subtly influencing species composition and interactions in the mesopelagic zone. Even their occasional deep dives carry ecological significance, as nutrients and organic matter are redistributed vertically through the water column. The sunfish's life history strategies, slow movement, large size, and immense reproductive output, interconnect with these ecological roles in ways that are not immediately obvious. While often perceived as inefficient swimmers, their drifting behavior maximizes energy use, allowing long migrations that connect ecosystems separated by thousands of kilometers. Each individual acts as a mobile node in a vast network, linking predator and prey, surface and deep water, tropical and temperate zones. The ocean sunfish, in essence, serves as an ecosystem engineer, creating subtle but widespread effects that ripple through marine environments. Human-induced changes to the ocean threaten to disrupt these ecological roles. Bycatch, plastic ingestion, and climate change can reduce sunfish populations, which in turn may lead to jellyfish blooms, shifts in predator-prey dynamics, and altered nutrient cycling. The decline of a single keystone species like the sunfish demonstrates how interconnected and delicate ocean ecosystems are. Protecting the sunfish is not only about preserving a unique species, it is about maintaining the health and stability of entire marine systems. The importance of sunfish in ecosystem resilience cannot be overstated. Through their feeding, migration, and reproductive activities, sunfish help maintain biodiversity, distribute nutrients, and regulate populations of both prey and predators. Their interactions with cleaner species enhance the survival of smaller organisms, while their presence connects surface and deep-sea ecosystems. Each sunfish is an agent of balance, demonstrating how one species can influence the ocean on multiple levels, both visible and invisible. In conclusion, the ocean sunfish is far more than a drifting curiosity. It is a central player in maintaining ecological balance, a keystone species whose life history and behaviors influence countless other organisms. Its slow, deliberate movements, massive size, and wide-ranging migrations make it a critical link in both horizontal and vertical oceanic interactions. Protecting the sunfish means protecting entire ecosystems, demonstrating the profound ways in which one extraordinary species can shape the natural world.
The ocean sunfish inhabits a world of extremes. Its environment spans surface waters warmed by sunlight to the cold, shadowy depths of the mesopelagic zone. Over millions of years, it has evolved a suite of adaptations, physiological, behavioral, and ecological, that allow it to survive, thrive, and navigate the vast, unpredictable expanse of the ocean. Understanding these adaptations offers insight into resilience, energy efficiency, and the remarkable strategies life develops in the open sea. Thermoregulation is among the sunfish's most critical adaptations. After deep dives into cold, nutrient-rich waters, sunfish often return to the surface to bask in sunlight. This behavior is not mere idleness. The giant body absorbs heat, restoring muscle function and metabolic efficiency. Observations show that sunfish tilt, rotate, and adjust depth during these intervals, optimizing exposure and warming at a steady rate. This strategy allows them to sustain prolonged feeding excursions in colder depths, combining behavioral thermoregulation with innate physiological resilience. Their swimming mechanics are uniquely suited to energy efficiency. Unlike fast, agile predators, sunfish lack a conventional tail fin. Instead, their dorsal and anal fins provide propulsion, moving in a slow, synchronous flapping motion. This generates forward movement while minimizing energy expenditure, a crucial adaptation for a species that must drift over thousands of kilometers and feed continuously on low-calorie gelatinous prey. The clavus, or rudder-like tail structure, stabilizes the body, allowing subtle adjustments in direction without requiring bursts of energy. Observers note that even in strong currents, the sunfish maintains orientation with minimal exertion, demonstrating a perfect balance between form and function. Buoyancy control further supports survival in diverse environments. Sunfish maintain near-neutral buoyancy, allowing effortless vertical movement between surface and deep waters. This adaptation conserves energy during long migrations and deep dives, enabling the species to exploit prey in varying ocean layers. Physiological studies suggest that specialized tissues and body composition, low-density flesh and gelatinous muscle layers, assist in regulating buoyancy, reducing the need for constant swimming. Their dietary specialization also reflects evolutionary optimization. Feeding primarily on jellyfish and other gelatinous organisms, sunfish consume prey abundant across depth gradients. Their massive, extendable mouths allow them to engulf swarms efficiently, while gill rakers filter tiny organisms from the water. Observations indicate that sunfish can adjust feeding behavior according to prey density, location, and composition, demonstrating not just a passive diet, but a flexible, adaptive foraging strategy.
Sensory adaptations enhance survival in a variable environment. Sunfish rely on multiple sensory modalities to navigate, locate prey, and detect predators. While vision is important near the surface, chemical and mechanosensory cues dominate in deeper, darker waters. Experiments and tagging data suggest that sunfish may detect thermal gradients, water pressure changes, and possibly geomagnetic cues to orient themselves over long distances. These sensory adaptations enable precise vertical and horizontal navigation across vast oceanic regions. Parasite management and symbiotic relationships are another key adaptation. The sunfish's thick, rough skin provides a substrate for parasite accumulation. To counteract this, sunfish utilize both behavioral and ecological strategies. They visit cleaning stations where small fish and birds remove parasites, bask near the surface to facilitate cleaning, and occasionally engage in deep dives to alter skin conditions and dislodge pests. These behaviors not only maintain health, but also foster interspecies interactions critical for ecosystem functioning. Reproductive adaptations ensure species continuity in a risky environment. Female sunfish produce extraordinary numbers of eggs, hundreds of millions in a single spawning event, compensating for high larval mortality. Timing of reproduction appears linked to environmental cues, such as water temperature and seasonal plankton blooms, ensuring that offspring have optimal conditions for survival. Juvenile sunfish possess unique morphological traits, including elongated fins and spines, enhancing survival against predators and increasing mobility in turbulent coastal waters. These life history strategies highlight the species' evolutionary ingenuity. Adaptation to predation risk illustrates behavioral intelligence. Sunfish demonstrate calculated defensive strategies, including vertical dives, lateral rotations, and drifting to obscure orientation. Their massive, flattened bodies may deter predators by presenting a challenging target, while scars and observed evasive maneuvers suggest that individuals learn from past encounters. Even without speed or agility, the sunfish survives by combining physical form, behavioral adjustments, and environmental awareness, a testament to the sophistication of slow-motion survival strategies. Extreme depth excursions reveal physiological tolerance. Tagging studies document dives beyond 600 meters, exposing the sunfish to low temperatures, high pressures, and minimal light. The species' cardiovascular and muscular systems accommodate these conditions, allowing extended periods at depth without damage. Such excursions provide access to prey unavailable to surface feeders and may serve thermoregulatory, navigational, or predator avoidance functions. Adaptation to extreme depth highlights the sunfish's flexibility and resilience in one of Earth's most challenging habitats.
Longevity and growth patterns also reflect survival adaptation. Sunfish grow slowly but steadily, reaching enormous sizes over years. This growth provides safety from many predators while optimizing energy allocation between feeding, migration, and reproduction. Large body mass enables extended migrations and a greater capacity for storing energy, ensuring survival even in resource-scarce regions. Each stage of growth, from tiny larvae to colossal adults, represents an adaptation finely tuned to environmental pressures. Finally, the sunfish's integration of multiple strategies is perhaps its most remarkable adaptation. Thermoregulation, efficient locomotion, buoyancy control, sensory perception, reproductive output, parasite management, predator avoidance, and extreme depth tolerance all interact synergistically. Each behavior and physiological trait complements the others, creating a resilient system capable of navigating the uncertainties of the open ocean. It is a living model of evolutionary optimization, demonstrating that survival is not about a simple feature, but the harmonious interplay of many. In conclusion, the ocean sunfish exemplifies extraordinary adaptation to a challenging and variable environment. Its slow, deliberate movements, giant form, and wide-ranging migrations are complemented by finely tuned behaviors and physiological traits, allowing survival across depths, temperatures, and ecological niches. Observing, studying, and understanding these adaptations deepens appreciation for evolutionary ingenuity and underscores the importance of conserving a species so integrally linked to oceanic ecosystems.
The life of the ocean sunfish begins in an almost invisible form. Unlike its enormous adult size, the sunfish's earliest stage is microscopic. Predation pressures, and evolutionary strategies that ensure the species' persistence. The life cycle of the sunfish, from tiny egg to massive adult, reveals one of the ocean's most remarkable survival stories. Spawning and egg production. Female sunfish produce one of the largest numbers of eggs of any vertebrate species, hundreds of millions in a single spawning event. This extraordinary reproductive output compensates for the high mortality rates of larvae and juveniles. Spawning typically occurs in warm, temperate waters, where currents can disperse eggs over wide areas, increasing the chances that some will survive and find suitable habitat. Observations suggest that spawning may be linked to lunar cycles, water temperature, and plankton abundance, ensuring optimal conditions for larval development. The eggs themselves are tiny, transparent spheres containing a yolk sac that provides the initial nourishment for the developing embryo. Despite their small size, they are fully equipped for survival in the open ocean, with a delicate membrane protecting them from minor physical stressors and pathogens. However, the eggs remain highly vulnerable to predation from plankton-feeding fish, jellyfish, and other marine organisms. Larval stage, navigating a perilous world. Upon hatching, sunfish larvae are just a few millimeters long and look drastically different from their adult counterparts. They possess elongated spines and a proportionally large head, adaptations that may help deter predators and improve stability in turbulent coastal waters. The larvae rely on yolk reserves initially, gradually transitioning to feeding on microscopic plankton. During this stage, survival depends on both luck and environmental conditions. Currents can carry larvae to nutrient-rich areas, increasing feeding opportunities, or into predator-dense zones where mortality rates spike. The larvae's tiny size and vulnerability mean that only a small fraction of eggs ever reach juvenile stages. Yet this high attrition is offset by the sheer number of eggs produced, a reproductive strategy finely tuned by evolution. Juvenile stage, growth and adaptation. As larvae develop into juveniles, their body shape begins to resemble the adult form, though proportions remain unusual. Long, flexible fins and a stubby tail are characteristic. Juveniles grow rapidly when food is abundant, feeding on plankton, small jellyfish, and other microscopic organisms. Growth is not uniform. Environmental factors such as water temperature, prey availability, and predator density heavily influence individual development rates. Juvenile sunfish often inhabit coastal and neritic zones, areas rich in food yet fraught with predators, including larger fish and seabirds. Their behavior during this stage includes hiding among floating debris, adjusting swimming patterns to avoid detection, and seeking out cleaning symbiosis when available. These early strategies lay the groundwork for survival in the open ocean as adults. Subadult stage, expanding horizons. By the time sunfish reach subadult status, they are noticeably larger, often exceeding several kilograms in weight. Their fins, body shape, and skin texture begin to resemble those of adults. Subadults gradually move offshore, entering open ocean habitats where food sources differ and predator interactions become less intense but still present. During this stage, sunfish refine their vertical migration strategies, learning to dive for prey and regulate body temperature efficiently. They also begin forming temporary aggregations, often in areas rich in jellyfish or near cleaning stations, preparing for eventual reproductive activity.
These years are critical for acquiring the skills and physical adaptations that support adult survival.
Adult stage, giants of the open ocean. Adult sunfish are among the heaviest bony fish in the world, with some individuals exceeding 2,000 kilograms. At this stage, they exhibit the full suite of adaptations for survival: energy-efficient locomotion, precise buoyancy control, deep diving capabilities, and thermoregulatory basking behaviors. Adult sunfish feed almost exclusively on gelatinous prey, maintaining their energy balance over vast migrations. Reproductive maturity is reached at several years of age, though the exact timeline varies depending on environmental conditions and individual growth rates. Adults participate in spawning events, producing millions of eggs and continuing the cycle that began in the open ocean as microscopic larvae. Mortality and longevity. Despite their size and adaptations, sunfish face numerous risks throughout life. Juveniles experience high predation, while adults contend with human-related threats such as bycatch, plastic ingestion, and habitat disruption. Natural predators, including large sharks and orcas, also pose a risk, though the adult's size and behavioral strategies reduce vulnerability. Life expectancy is thought to span decades, though precise data remain limited due to the difficulty of long-term tracking in the open ocean. Longevity allows the sunfish multiple opportunities to reproduce, compensating for high early life mortality and ensuring species continuity. Environmental dependencies. Each stage of the sunfish life cycle is intricately linked to environmental conditions. Temperature, currents, prey availability, and predator presence influence growth, behavior, and survival. Changes in ocean conditions, driven by climate change, pollution, or overfishing, can disrupt these processes, highlighting the delicate balance upon which the species depends. Life cycle summary: an evolutionary marvel. From tiny, transparent eggs to massive ocean giants, the sunfish's life cycle embodies evolutionary adaptation and resilience. Each stage presents unique challenges and requires specialized behaviors and physiological traits. Together, these stages form a continuous thread of survival strategies that have allowed the species to persist for millions of years, even in the face of predation, environmental variability, and human impacts. The ocean sunfish has long captivated human curiosity, but it is only in recent decades that technology has allowed scientists to study this enigmatic giant in depth. Modern research combines satellite tracking, underwater observation, tagging, and artificial intelligence to reveal behaviors, migrations, and ecological roles previously hidden from view. These advances are transforming our understanding of the species, turning myths and assumptions into data-driven insights. Satellite tracking and migration studies. One of the most transformative tools in sunfish research is satellite tagging. Tiny, waterproof devices attached to the dorsal fin provide continuous data on location, depth, and environmental conditions. Through satellite telemetry, scientists have mapped sunfish migrations across thousands of kilometers, revealing astonishing patterns. Some individuals traverse entire ocean basins, moving between temperate and tropical zones, while others maintain seasonal loops near nutrient-rich waters. These studies have uncovered previously unknown behaviors, such as long-distance dives into cold, deep waters and repeated surface basking. They also allow researchers to identify critical habitats, feeding grounds, and spawning sites, informing conservation strategies that protect key areas essential to survival. Deep-sea observation and submersibles. Advances in submersible technology and remotely operated vehicles, or ROVs, have provided unprecedented access to the depths where sunfish feed and navigate. High-resolution cameras and sensors capture interactions with prey, predator encounters, and even social behaviors. Observations reveal that sunfish are highly adaptable, adjusting depth, orientation, and movement patterns in response to environmental changes. Submersibles have also documented previously unseen behaviors, such as brief leaps or rolls, that may play a role in parasite removal or social signaling. These glimpses into deep water activity have expanded our understanding of how the sunfish balances energy conservation with ecological demands. Tagging for physiology and behavior. Beyond location data, advanced tags measure internal physiological parameters, such as heart rate, body temperature, and movement intensity. These tags provide insight into energy expenditure during deep dives, long migrations, and feeding activities.
By correlating physiological data with environmental conditions, researchers can understand how sunfish optimize survival in diverse and challenging habitats. For example, tagging studies show that sunfish adjust their depth to maintain optimal body temperature after cold water dives, confirming hypotheses about thermoregulation. Similarly, acceleration sensors reveal subtle fin movements that allow efficient locomotion, illustrating the sophisticated mechanics underlying what appears to be slow, awkward swimming. Artificial intelligence and data analysis. AI-driven analysis has revolutionized sunfish research. Machine learning algorithms process massive datasets from tags, cameras, and environmental sensors, identifying patterns in movement, behavior, and interactions. AI can detect feeding events, predator avoidance, social interactions, and even changes in swimming posture with remarkable accuracy. These insights help scientists predict how sunfish respond to environmental changes, track population health, and identify potential threats from human activity or climate change. AI allows researchers to focus on ecological questions rather than being overwhelmed by data, accelerating discoveries about this complex species.
Although sunfish are largely silent compared to marine mammals, acoustic sensors have been used to monitor their movement and interactions. Changes in ambient noise, water currents, and the presence of prey or predators can be inferred from acoustic data, helping researchers understand the environmental cues guiding sunfish behavior. Combined with visual observation, these methods reveal a multi-sensory perspective on how sunfish perceive and navigate their world. Citizen science and observational data. Modern technology has also enabled public participation in sunfish research. Divers, fishermen, and recreational boaters contribute sightings, photographs, and behavioral observations through coordinated citizen science programs. These contributions expand geographic coverage, providing data from regions where formal research is limited. Long-term records collected by enthusiasts have helped track migration trends, seasonal patterns, and population changes, demonstrating the value of community engagement in marine science. Discoveries about social behavior. Through these combined technologies, researchers have begun to appreciate subtle aspects of sunfish social behavior. Temporary aggregations at feeding grounds, interactions with cleaner fish, and occasional approaches to divers suggest a nuanced understanding of their environment and coexisting species. AI-assisted analysis helps quantify these behaviors, allowing scientists to distinguish between individual variability, learned responses, and environmental influences. Feeding strategies and ecological impact. Data from tracking and observation have also shed light on feeding strategies. Sunfish adjust their vertical and horizontal movements to optimize jellyfish capture, exploiting currents and prey densities to conserve energy. This feeding efficiency impacts gelatinous populations, nutrient cycling, and broader ecological networks. Without these technologies, such intricate details would remain speculative, reinforcing the value of modern tools in understanding ecological dynamics. Conservation applications of technology. Scientific discoveries directly inform conservation strategies. Identifying migratory corridors, critical feeding areas, and reproductive zones allow targeted protection measures. By integrating satellite, physiological, and behavioral data, policymakers can implement fishing restrictions, establish marine protected areas, and reduce bycatch. Additionally, AI models can simulate future scenarios, predicting the effects of climate change or human activity on sunfish populations, enabling proactive management. Challenges and future directions. Despite technological advances, challenges remain. Sunfish live in open oceans, often far from research vessels, making continuous monitoring difficult. Tag loss, environmental variability, and individual behavioral differences complicate analysis. However, ongoing innovation, smaller, longer-lasting tags, autonomous underwater drones, and improved AI algorithms continues to expand our capacity to study these elusive giants. Future research aims to integrate genomics, physiology, and environmental monitoring, providing a holistic understanding of sunfish ecology and resilience. By linking behavior, health, and environment, scientists hope to anticipate changes, mitigate threats, and ensure the long-term survival of this extraordinary species. In conclusion, modern technology has transformed the study of the ocean sunfish from anecdotal observation to precise, data-driven science. Satellite tracking, submersibles, tagging, AI, and citizen science have uncovered behaviors, ecological roles, and survival strategies once hidden beneath the waves. Yet even with these tools, the sunfish continues to inspire awe, reminding humanity that the ocean remains a frontier of discovery, and that understanding one of its largest and strangest inhabitants requires patience, ingenuity, and respect. The ocean sunfish, resilient over millions of years, now faces unprecedented challenges. Climate change, pollution, overfishing, and habitat disruption are reshaping the oceans in ways that directly affect this gentle giant. Understanding these threats is critical not only for the survival of sunfish, but also for the health of entire marine ecosystems, where the sunfish plays a pivotal ecological role. Rising ocean temperatures. Global warming has caused significant increases in sea surface temperatures, which directly affect sunfish behavior and distribution. Warm waters influence spawning cycles, prey availability, and migration patterns. Sunfish often rely on seasonal temperature gradients to locate optimal feeding and breeding grounds. As these gradients shift, traditional migratory routes may become less predictable, potentially disrupting reproductive timing and survival rates. Observations indicate that sunfish may begin appearing in previously cooler regions, while traditional habitats may become inhospitable. These shifts could lead to competition with other species for resources and even increased encounters with predators or human activity, creating new survival challenges. Ocean acidification and ecosystem impacts. Increased carbon dioxide absorption lowers ocean pH, altering the physiology of many marine organisms. Gelatinous prey species, such as jellyfish, may respond variably to acidification, sometimes proliferating in ways that disrupt local ecosystems. While an increase in jellyfish could temporarily benefit sunfish feeding, broader ecosystem imbalances, such as reductions in plankton diversity, may indirectly impact their nutrition and energy intake. Acidification also affects coral reefs and coastal nursery habitats, which are critical for juvenile sunfish development in some regions. Plastic pollution and ingestion hazards. Plastic debris is a persistent threat to sunfish, which feed on jellyfish and other gelatinous prey species. Floating plastic bags, balloons, and synthetic debris closely resemble natural prey and are often ingested. Ingested plastics can block digestive tracts, reduce nutrient absorption, and lead to starvation or internal injury. Microplastics present another hazard, potentially impacting physiological health over time. Conservation campaigns aim to reduce plastic waste entering the oceans, but mitigation requires global coordination and public awareness. Bycatch and fishing pressure. Despite their size, sunfish are frequently caught accidentally in drift nets, long lines, and trawls targeting other species. Bycatch mortality presents a major threat, particularly in regions with intensive fishing activity. Regulations and fishing gear modifications, such as exclusion devices and temporal fishing closures, have demonstrated success in reducing sunfish mortality. Ongoing monitoring, supported by satellite tracking and AI analysis, helps identify high-risk areas and informs targeted conservation measures. Coastal development and habitat loss. Juvenile sunfish often rely on coastal nurseries, estuaries, and shallow bays where food is abundant and predators are relatively fewer. Expanding coastal development, pollution, and habitat modification threaten these critical early life habitats. Loss of nurseries can have cascading effects, reducing juvenile survival and ultimately adult populations. Protecting these areas through marine reserves, pollution controls, and sustainable development policies is essential for maintaining population stability.
For centuries, the ocean sunfish has inspired curiosity, awe, and even superstition among humans. Early sailors referred to it as the sea bream or moonfish, often mistaking it for floating debris or mythological creatures. Today, with modern technology and growing conservation awareness, humans are learning to interact responsibly with sunfish, contributing to both scientific understanding and the preservation of this extraordinary species. Diving encounters, a window into behavior. One of the most direct ways humans observe sunfish is through diving expeditions. Divers describe moments of astonishing stillness, where a sunfish glides past, its enormous, flattened body casting a slow, deliberate shadow in the water. These encounters reveal behaviors that are rarely documented in textbooks: subtle rotations, careful fin adjustments, and the patience with which sunfish allow cleaner fish to remove parasites. Some divers report that adult sunfish display curiosity toward humans, approaching slowly, turning to inspect divers, and even mimicking subtle movements. Such interactions underscore the species' intelligence, awareness, and capacity to coexist with non-threatening observers. Citizen science contributions. Across the globe, citizen science has become a critical tool in understanding sunfish populations. Recreational boaters, fishermen, and coastal communities contribute sightings, photos, and behavioral notes to centralized databases. This collective effort provides a wide-scale, cost-effective method to track migrations, identify feeding grounds, and monitor population health. In Japan, for example, local fishermen submit sunfish sighting logs, contributing to research on seasonal abundance and reproductive activity.
In the Mediterranean, divers upload images to online platforms, helping scientists identify individuals, track scars, and monitor interactions with other species. Citizen science creates a bridge between human curiosity and scientific research, enabling broader conservation engagement. Marine Protected Areas, MPAs, in action. MPAs have proven particularly effective in supporting sunfish populations. In regions where human activity is restricted, sunfish are observed more frequently, exhibiting natural behaviors with minimal disturbance. Protected feeding grounds allow individuals to replenish energy efficiently, while spawning zones provide safer conditions for eggs and larvae. Success stories include MPAs in parts of the Pacific and Mediterranean, where careful enforcement.
Thank you for joining us on this journey into the world of the ocean sunfish. Don't forget to subscribe for more fascinating marine stories, and we appreciate your support.